Today's notes are going to cover what's called literal equations, and that really just kind of means that you've got an equation with multiple variables, and you're going to be asked to solve for a specific one of them. In this first equation, we've got E equals mc squared. I'm going to ask you to solve for C. Well, I could ask you to solve for M. I could ask you to solve for E, but E is already solved for. So if I ask you to solve for C, what I'm really asking you to do is I'm asking you to isolate C. So I want the equation to be C equals and everything else on the other side. It's the same steps as if I gave you, let's say, an equation like 4x plus 3 equals 10, and you want to isolate the x. You know what steps to do that. I think the easiest way to think about it is kind of move outside in. So move the furthest things away and then whatever is right next to it. Here, I only have to move a couple things. I need to move the m and I need to move the squared. Well, the m and the c are side by side with no signs, so we know that they're being multiplied. So the opposite of multiply, if I want to break the m away from the c, is to divide it, because then m over m will cancel, and I'll c squared left by itself. So just one step closer to having c alone. But whatever I do to one side of the equation, I have to do to the other. So right now I have e divided by m equals c squared. And there's nothing I can do to simplify e over m. There just is what it is. Now the only other thing I need to get rid of so that c is by itself is this squared. You know that square rooting is the opposite of squared, and so it will cancel and leave us c all by itself, which is that was my goal. Isolate c. Okay, but if I square root one side, I have to square root everything that's on the other side. Again, there's nothing I can do to simplify. So the square root of e over m is equal to c. So I have successfully solved for c because c is by itself. The next equation, a equals 1/2 bh, and I want to solve for b. So if I want b alone, the first thing I notice is that I have 1/2 times b times h. And if everything is being multiplied, then the opposite of that is to divide. But it's weird to divide by a fraction, so let's just get rid of the h first. So the h's cancel. I have 1/2 b. I'm closer to getting b by itself. And a divided by h I can't do anything with. Now 1/2 b is really the same as saying, let's see, 1 over 2 times it's b over 1, right? So it's really like saying b divided by 2, and the opposite of that is to multiply. So if I multiply this side by 2, it will cancel the 1/2, because 1/2 and 2 whole is just 1 whole. So I have b equals, but I have to multiply this side by 2. Well, that's kind of like 2 over 1. So 2 times a is 2a over h. So 2a over h is the same as b. All right, this next equation we're going to solve for w. W is stuck inside of the parentheses, and I can't touch anything inside the parentheses until I get rid of everything that's outside of the parentheses. This 4 is outside and being multiplied to the parentheses. So in order to isolate w, I have to get rid of that 4 first so that I can break apart the parentheses, because now I just have w minus 1. 12v divided by 4, because you have to do the same thing both sides. 12 divided by 4 is 3. Okay, now to get w alone, I need to get rid of the minus 1. The opposite of minus 1 is to add 1. So those cancels. I have w equals 3v plus 1. Those are not like terms. So I can't do anything but keep everything that I have. I have a 3v and a plus 1. And that is what w is equal to. Number 4, I'm being asked to solve for h. Well, h has been a weird predicament because it is stuck in the bottom of the fraction, and I can't get h by itself until I break apart the fraction. In order to break apart a fraction, you multiply by the denominator. So that will cancel the denominator on this side and leave me just k minus 5, but I have to multiply on this side too. 1 times negative h is negative h. All right, now I want h by itself. Well, so I'm in this kind of crazy situation where I have h, it looks like itself, but remember it's really like a negative 1 times h. So I divide by negative 1 so that I have h by itself. Divide by negative 1. K divided by negative 1 is negative k. Negative 5 divided by negative 1 is positive 5. And that is what h is equal to. All right, question 5. I want to solve for p. What's weird in this one is that I have 2 p's. Well, I can't isolate p or get p by itself until I have p written only one single time. So what we're going to do first in this one is we're going to factor it. I have two terms, a p and a PRT. Both of those terms have a p, so I can take the p out by dividing and write down what's left over. So p divided by p is just one whole. PRT divided by p is RT equals A. Now, all of this 1 plus RT is being multiplied to the p. And if my job is to get p alone, I need to break that stuff away. If it's all being multiplied, then to break it, you're going to divide. So I have p times 1 plus RT. So a factor of 1 plus RT on top and a factor of 1 plus RT on the bottom cancels. You need to put 1 plus RT in the bottom of the side, and there's nothing you can do to simplify that. So A over 1 plus RT equals P. All right, last example, we're going to solve for H. So right now I have a 1/2 being multiplied to the H and the H being multiplied to a D plus B. I'm going to get rid of D plus B first because I can divide by that whole factor and they would cancel, but I have to do the same over here. So I have A divided by D plus B equals 1/2 H. And remember, 1/2 H, just like we talked about earlier, is really the same as H over 2. So to get rid of that, we're going to multiply by 2 whole. 1/2 times 2 is just one single H left over. Multiply by 2 on this side, so it's really 2 over 1. So I have 2A over D plus B is what H is equal to. And that's it.